Hi, today we're going to talk about file system structure. So what I want to do today is just talk about a little bit about secondary storage, just a little bit of a review, define design concerns that we need to think about when designing a file system, and talk about the layered approach, which is the most common approach the most OSs take. So a little review of secondary storage, really big overview. Just recall, so file systems are written to these disks, and disks are great for this because they have random access, they're rewritable. So we had our HDDs, and these were partitioned into sectors, and each one of these were considered a block, and that's how much that the unit of data transfer. So thinking of that, keeping that in mind, and then of course we had our blocks here in our NVMs. So thinking about that, we have to figure out a way that our file systems and our files themselves can be stored such that they fit into these block structures that are already occurring in each one of these secondary storage devices. So the main design considerations, one is a user-centric concern. We want to figure out how do we want the file system to look and behave for the user. So this is what file attributes do we want to have for each file that they can see, what kind of operations can they do on files, what the directory structure will be that they actually get to see and interact with. And then the second is that we need to design algorithms and data structures to actually map these logical files to secondary storage devices. And some popular data structures here that we'll talk about in future videos are arrays, hashes, and trees. So most file systems are structured in a layered fashion. So each layer uses functions from the lower levels. So as you go down, this application programs will use functions from the logical file system, so on and so forth. So a little bit about each layer. So I/O control layer is where all the device drivers and interrupt handlers sit. So this is where the disk talks to your main memory or transfers. This is what facilitates the transfer of data between the disk to your RAM. The basic file system is what communicates with those device drivers. It also handles I/O requests, scheduling, and manages any buffers and caches. The file organization module, so this is the one that knows about the files, it knows where their logical blocks are, and also contains the free space manager that we'll talk about in a future video. The logical file system here manages all the metadata, so all the file control blocks, and also manages the directory structure. And I'm not going to talk about the application programs because that is just applications. So another thing to note here is most OSs support several different file systems. For example, Windows supports FAT, FAT32, NTFS, and also those used by CD-ROMs and DVDs. Linux supports over 130 different types of file systems, or different structures of file systems. The most standard is ext3 and 4. But this is a really active field of research because we want to find out how we can structure our file system such that it's the most efficient and the fastest as possible. As promised, it was a short video, or I don't know if I promised that. I've recorded this one about 5 times, so at some point I promised it. But short video, so let me know if you have any questions, if anything needs to be clarified.